Yeah. So I also mentioned that we are going to learn ETL tool. ETL in the sense extract, transform, and load. Extracting the data from the source system, transforming the data, and loading it to the final database. So Python will be solving this kind of stuffs by using the data frame concept. Okay. So today we are going to use the extraction by Python data frame. Okay. Extraction means how we can connect with different source system and pull the data from their source system. Okay, the source system means if you can remember during BI classes, I mentioned that the source systems are just like Excel. It can be flat files, Excel, CSV, some JSON files, just like this. It can be different OLTP databases, just like it can be a MySQL database, it can be a Oracle database. Okay, so this kind of databases can be there. There should be different API. You can directly connect with Python and pull the data. So source system can be various in a particular project or in a particular application. Source system can be various. Your job should be pulling all the source system. First of all, they should be connecting all the source system. Maybe there are interface issue. Okay, you're not able to connect to the source database. So the first step should be you need a good connection with the source database. Then only you can pull the data. Okay. So during extraction layer, we are pulling the data and storing it in Python data frame. Okay. You can tell this is a staging layer where we are pulling all the data and pushing it over there in a data frame format. So whenever all the data frames are ready, means we pulled all the data from the source system. Then what we can do, we can go ahead with the transformation part. We can transform the data, okay, in different data frames. So this should be our second step. Let's learn the extraction layer with few examples one by one. So first thing is create data frame from a CSV or XLS file. Basically, we can tell create data frame from flat files. Okay, how to do that? I'm opening my PyCharm. So this was last day's programming part, how we are creating data frame on top of a list, on top of a dictionary, just like this. So I'm removing that part. Okay, so I'm going to pull some record from a flat file. Let me put some flat file over here. Okay, I put the flat file over here. This is an CSV file. Let me check whether this is a CSV or not. Let me check the properties. Yes, it's a CSV. .csv is the extension. Okay, let me check what the CSV file contains. I can open the CSV by editing it. Open with Notepad++. Okay, this is the CSV file. Comma separated delimiter. You can see each of the field is separated by a comma. Name, subject, age, marks. Okay. Swapnil history 13,600. This is the marks of the student for particular school or particular classes, such as like this. Okay. I can also open this kind of sheet by Excel format as well by double clicking on it. Okay. So let me pull this into our data frame. I'll be connecting this thing, this file structure. Maybe I'll be calling this file structure means this path and the particular file over here and push it to data frame. Okay. First of all, let me import pandas because I'll be going to use pandas. I'm aliasing as PD. Okay. Then I can directly use, I'm creating a data frame called DF where DF equal pd dot read CSV. It's a function. In pandas, there is a function called read CSV. Okay. Between that, I can call the particular path over here. You can right click on top of this. Copy as path. I'm pasting it over there. Path means it's copying the entire drive. C users, this kind of file structures are there, so that is why it's printing this way. There are double quotes. I already put a quotes there, and they are also taking a quote. So I'm removing this quote, one of the quotes. Okay, so this is the particular CSV I'm going to import. But if I'm running this job, that thing should be having error because I think I didn't told that thing. So this kind of backslash has been used also for a escape character. Okay, so black backslash in this kind of quotation, they will be thinking this as a escape character. They do not, the Python interpreter will not be able to see this thing as a string character over here. But this is a string. If I want to read a path, this is the segregator for the hierarchical root structure or just like this. Okay, so for that thing, I need to put another backslash. The first backslash is the escape character, and the second one is, the first one will be helping the interpreter that the second one is the string to read. So each of the backslash should be replaced with a double backslash. Okay, this example I'll be showing again with a print statement. Then that thing should be clear to you. So I'm just replacing one backslash with a second backslash so that the interpreter should read the file properly. Okay, I have put this thing. So what I'm doing, I'm reading this CSV and pushing the output to this data frame. And let me print the data frame now. Let's see whether it's able to pull the Excel or sorry, the CSV file into this data frame. I'm running it. Just let me update to test to. Yes, it's updated and you can see the output is here. Okay, it is having the proper output. Hope there is no doubt. Similarly, if we have any other file structure, file format, just like Excel, we have Excel over here. Okay, so just I'm putting read underscore, you can see what are the different format. SQL is not a flat file format. So feather is there. Those are different file format available. HTML, Parquet, Pickle. So those are different file format. Whatever file format user will be sharing with us to be read. So the same kind of things we need to use over here. Okay. In the exercise, I'll be giving you to read data from Excel sheet. In a particular Excel, we have different sheet. So you need to read each of the sheet in the same Excel and create separate data frame. Okay, I'll be giving this exercise maybe tomorrow. Tomorrow, day after tomorrow, when we'll be finishing Python extraction, transformation, and loading part. So one more important concept. Over here, we are pulling the data or pulling the flat files information from a local system. Means I have saved the flat file over here and the same flat files I'm calling through my Python interpreter, which was also installed in my local system. But in your practical purpose or in your project, you should be having the Python interpreter should not be installed in your local. Even the file will not be saved in your local. File can be saved maybe some S3 bucket. Suppose your project is using AWS account, you have a S3 bucket. So the file is been saved over there. So for that thing, you need to, call the S3 location by the same way how S3 location is called. You need to put the same thing over here. When you are running the Python jobs, just you need to upload it. Suppose your file is in HDFS location. You need to put the HDFS location in this way. Okay. Let me tell one more concept. Why we are putting this double backslash over here. If we just go ahead, suppose I'm going ahead with the print statement. Okay. Suppose I'm doing a print statement. I'm putting single quote there. Suppose I'm putting Soptic. I'm ending the quote over here. Okay. So this is my starting code. This is my ending code. Inside the code, I'm passing the string where I'm mentioning apostrophe. I am Soptic. This thing will throw an error because I'm using a single quote in between. So the interpreter will be understanding this is the starting code and this should be the end code. And then why this character is coming over here? So that is why they will be throwing an error. They will not understand that this apostrophe is not a quote. Open or close quote. This is a apostrophe. This is a part of the string itself, the entire string. Okay. So if I'm running it, it will be failing. For that thing, we can use a backslash over here. If I use a backslash will help the interpreter to understand that the next character after the backslash, it's a string character. It is not something to interpreter just to understand this is a different thing. Just like this. If I put it, backslash will not print. You can see, but the proper apostrophe will be printing over here. Similarly, in this statement, if we put slash, then a directory or folder name, the slash is been considered as this backslash. So we need to help the interpreter to understand. Yeah, of course, there's a backslash. The first backslash is just to neglect the second one, not a interpreter keyword or just like this. It's a strings part itself. Okay. Hope this is understandable. Okay. Any doubts so far from anyone? I believe no. Okay, now we are going ahead with some more interesting part. We successfully imported data from a CSV. Now we'll be going to connect a database. Okay, a database just like let's connect to a MySQL database. MySQL is already there in our system. Let me open that MySQL. I'm opening the MySQL workbench and I'll be connecting the database from here. So the same database I'll be trying to connect by the Python interpreter. So you can see we have the database data training and all those tables we have created during our SQL classes. Okay, so suppose let's pick one of the table, employee table, the main table that we use that time. Let me put a select star from the table name. So you can see this is the result or data output of employee table. Okay, so let's connect this database, the MySQL data. While connecting to the MySQL database, what are the different input parameters? Let me show you once more time. So the input parameters is the server name it's a local server. The username, that is root over here. The port name is 3306. And while trying to double click over here, I need to put a password. This is also a parameter to connect our MySQL DB, MySQL database. So all those connection parameter I need to put somewhere to authenticate my SQL server. And when the authentication is successful, when we are able to create a connection there, then we can easily pull the table into our data frame. Let's go ahead with that part. Going to another page. I mean, it's a different page. So where I'm just importing pandas, I'm importing another libraries. It's a different one. It's called SQL Alchemy. So this library will be helping me to connect with an external database. Okay. So I'm just importing this create engine. Create engine is a class. So from SQL Alchemy, I'm importing create engine class over here. All the classes are not required. Only I'm just importing this one because this should be helpful while connecting to the database engine from my Python interpreter. Okay. Hope that is understandable. Okay. Now in the next line, I'm creating the connection engine. I'm just giving the name engine. Engine equal. So I'm calling this class create engine and I'm passing the input parameters there. What are the things? So what database I'll be going to connect? MySQL. Over here I just to mention MySQL plus py MySQL. Both of the things I can connect. Then put a colon, double slash, the username. Okay. Then after a colon, I need to put the password. This is my password. Okay. While putting the password over here, those are encrypted. I'm putting it. I have to put it over here. If we have any encryption tool, definitely we can try this thing. But as of now, as we are designing it with a very simple manner, so I'm putting the password over here just to show you whether the authentication is successful or not. Okay. At the rate, this is my server name, which is localhost. Okay. Colon, the port name slash the database name, tetra underscore trading. Okay, so all those input connection parameter, I'm putting it over here. The database name I can put, I cannot put, that is totally as of my wish, because there are lots of databases available over here, database schemas. Okay, so those are the database schemas available. So if I just want to make anything as default, then I can mention it over here. Otherwise, we can remove it. I can connect till this part. So whenever I need to pull any tables information, I need to pass the schema name there with a mandatory manner. Okay, so this is how we can create this object. Engine is my object. Now let me just use the pandas data frame read SQL. I'm creating data frame df equal pd dot read SQL query. This is the function read SQL query. The last example I put read CSV. Over here, I'm passing read SQL query. And the query I'm passing it over here, just like select star from employee. Okay, only employee will not work over here. I need to mention the database schema as well. Let me quickly try it over here. If I need to pull in this way. Select start from tetra underscore training dot employee. Okay. So this thing is the coding part. Let me put the same thing over here in my PyCharm. Okay. Select start from tetra training dot employee. I'll be reading the data from this output and pushing it to this data frame. Okay. So while reading it, I need to mention the connection engine over here as well, which I have created in my last step. The connection engine's name is engine only. So let me just pass this parameter as well. Because when I'm using this function read SQL query, I need to pass two mandatory parameter. The first one is the SQL query itself, and the second one is the connection identifier. Okay, which I have created in the previous steps. Hope you can able to see that thing. Now let me print the data frame. Let me change hello world. Hello world. Okay, let me run this. Yes, it's successfully able to read the table. The table is employee. So in this line, they are able to successfully have a connection, good connection setup with the database. The connection was successful. Now in the next step, they are fetching the data with that connection identifier engine. Okay, I hope the thing is understandable. If not, please tell me because this is very, very important one. We are successfully able to connect the external database and able to pull the data into data frame. Okay, so one more important concept. Over here, we are able to connect to MySQL. Similarly, if we want to connect different source system, suppose our source system is not a MySQL one. Maybe it's a different database, just like a Oracle, just like MS SQL Server. We can use the same engine, same SQL Alchemy libraries over here. Just we need to pass different parameters. Over here, it should not be MySQL. For Oracle, it can be Oracle. For Snowflake, it can be Snowflake. So whatever database I'll be trying to connect, I need to pass the exact parameter of this database. It's a Snowflake. Then I need to put the proper username, the password, the server name where this particular database is installed, and the port name, port number. Okay, so those are the mandatory fields I need to insert over here. Any doubt so far from anyone? Please tell me. No doubt? Okay. I'm assuming there is no doubt as there is no question. So this is how we are going to create the data frame based on the database. So those are the two examples for the extraction. I'll not be going ahead with different examples. As I mentioned, we can customize it. Those are the basic things. We can customize it as we require it. Okay. Maybe in exercise, I'll be giving you some Snowflake database. So you'll be connecting your Python interpreter with the Snowflake database and you can pull the data from there. Let me know if there is any issue while pulling the data from the Snowflake. I found some new people joined. Rosni, you joined multiple times. Not sure. Is there any issue?
No, I was just outside, so I'll disconnect this side.
Okay. Okay, so those are the examples of the extraction, how we can extract this. But this is a basic thing. During maybe in your project, you will not be using this kind of password directly because password should not be, we cannot show in our code. The password cannot be showed inside the coding part. So maybe there can be some encryption tool. Okay, the encryption tool will help the encrypting and decrypting part. Maybe I need to put the original password in encryption tool and I need to encrypt that thing. And I need to put all the encrypted password, password over here. So while running this Python interpret, this kind of code, first, when I'll be calling this kind of things, I need to use some decryption as well. So first it will be decrypt the password and passing it over here and then it will be running. So this kind of encryption tool we can use. Okay. And as I mentioned, separate database should be there. So I need to change it accordingly. But this is the general extraction layer, how we should work. Now, the next thing we'll be going ahead with the transformation part. Extraction is very simple. With the two examples, it's sufficient you to, sufficient for that to you to understand. But we need to read for different database to connect. Not reading part. When different database will be coming into picture, we need to have a quick hands-on and we need to check whether we are successfully able to do that or not. Okay. Now moving to the next part, transformation. I'll be going ahead with few of the transformation, but tomorrow I'll be showing the rest of the transformation. Transformation is a huge thing, just like in SQL when we are learning the DQL part. Okay, DQL, it was a huge thing. Similarly, transformation on top of these data frames, what kind of transformation we can do. So those are called Python transformations or data frame transformation. Let me go ahead with the few of the few transformations today, one or two. Let me show one by one. So we can successfully able to create data frame on top of MySQL database. Okay. So first thing is indexing and slicing of data frame in the transformation. So you can see one thing, when we are creating a data frame from maybe from a CSV file from a database, this kind of indexing part, it was not there in the database or in the flat file. I'm opening the database, you can see there is no index 0, 1, 2, 3, 4. Okay, so while calling any data frame, pandas data frame, by default it will be giving some row level indexes, and this is the thing which is very helpful. It will be helping to determine how many rows are there with the end. Along with that, we can put some unique identifier over here as well. If we do not have a primary key, then data frame index will be helping us a lot to understand this kind of primary keys concept. Okay, but over here we can see employee ID is a unique and primary key is also available in the data set. Okay, employee ID is not a duplicated one. Each of the employee, it's having its own employee ID. So we can change the index during any kind of Python transformation. How we can change it? Just like uh, I'm putting the print statement over here. I'm just updating df dot set index. It's a method on top of this data frame. Set index over here. I can pass which column I need to make a index one. Suppose I want to make index the employee ID. Okay, df set index employee ID. I'm going to run it. This was my original one, and the second one after converting the index. So you can see this 0, 1, 2, this kind of index, it's not there anymore. And the the employee ID alignment, it's a bit left and starting with the bottom section because now the index has been modified. Employee ID is the index. I can use multiple columns as index as well. I can also pass the department one. Okay. But if we put multiple elements over here, I need to pass these things maybe in a tuple or any list. I'm declaring a list over here. Otherwise, a error message will be appear while I'll be executing the Python code. Okay, so you can see the alignment has also modified for department. So this is how we can modify the indexing part. Hope this is understandable. So this is called indexing. I can change the index. Suppose I'm just declaring this thing as df1. df1 will consist the information having with the updating the in default index by some columns. Okay, this way you can do it. But if we just want to uh, change the index, reset the index with the default one, you can just put df1 dot reset index over there. Just I do not have to pass anything. It will be resetting and the old format should be available. So we just learned set index and reset index on top of data frame. Just remember it. So you can see after putting reset index, it is back to the original one, the data frame df. Okay. So I'm just passing the value on top of df1 after setting index. On top of df1, I'm applying reset index. You can see it's back to the original form. Okay. So this is called indexing, different indexing strategy or method. Based on our project, based on our data architectures and all, we need to define the index part properly there. Now, slicing, data frame slicing means the column level filtering. Suppose I don't want to see all the columns at a time. Okay, it's like employee ID, employee first name, employee last name, experience, salary, department, data part. I don't want to see all the columns at a single glance. I want few columns to see. So that thing is called slicing. During SQL, we learned just like select column names with having some delimiter, then from table name. Over here, we can do the similar way, just like data frame. Whatever column I need to see, I can declare this thing within a list. The first square bracket, it's a mandatory one, just like data frame and putting the square braces over here. It's a mandatory one. Okay. Inside that one, I'm declaring a list. The second one is a list. Inside this list, I can mention whichever column I want to print. Okay. Suppose I want to print employee ID only, then employee first name. Last name I do not want to print. Maybe experience within. Okay. Let me just put a print statement on top of it. Okay. So this is the output. How we are slicing it. But just remember the square bracket. When we'll be doing any kind of data frame operation, by default, we are putting this square bracket. And the internal square bracket is nothing but a list. We are successfully able to slice it. The second example is for slicing part. Okay. Now, if we just go ahead with the row level filtering, this is called filtering operation. In SQL, we have used this thing, putting where clause. Okay, so how we can do the filter over here? So this is our main data frame. Suppose I want to filter it, I want to see only the IT related employees data. Okay, so we can put in this way. We need to put the condition in this way. Df dot department equal IT. Sorry. This is the condition I'm putting it, and the condition should be imposed on top of a data frame. So I'll be printing this data frame, and in the clause I'm mentioning the condition. The department should be IT. Let me do a print statement on top of it. Okay, you can see employee ID, employee first name, employee last name, experience, salary, department, all the data, all the columns are mentioned over here, but the records are only IT. Okay, because we have put a condition over here. Unlike SQL, in SQL we can do slicing and filtering statement at a single executional statement. We can use that thing, but over here I cannot use that thing. In the same statement I cannot slice. We are filtering it over here. We cannot slice it. To do a slicing part and filtering part in the same statement, we need to use some different method. I'll be showing this thing in tomorrow's session. Just like .loc or .iloc. This kind of thing we'll be learning in tomorrow's session. Till now, any doubt? Whatever we are learning, is it fine for everyone? Please tell me. Is this is understandable? Not getting response from anyone. Please listen this thing carefully. If there is any doubt, please ask me question. I am hoping that there is no doubt. But if there is any doubt, please tell me. Okay, because this is very very important concept. Okay, thanks Shiva. Okay, so we are able to successfully, I mean, put the filtering part over here. I can put multiple filter conditions. Just I can put a AND clause over here, this kind of and I can put also separate filter condition. DF department equal IT. I'm also putting DF maybe salary greater than 50,000. Okay, I'm putting 50,000 only. 90,000, 51,000, and 85,000 will be returned. This one will be discarded. Okay, if we do put this kind of thing. Let me run it. Okay, someone just respond. Okay, thanks, student. So I'm printing it over here and putting conditions department equal IT and salary greater than 50,000. When putting this kind of condition, I need to wrap this thing within bracket. The first condition in this brace and the second condition I'm also putting within a brace. Okay, I hope this is clear. Let me print it. Yes, you can see only 3 records are available whose salary is more than 50,000, as well as the employee must be in IT department. This is for the first and second condition respectively, one by one. Okay, let me print. Let me print some dot line to understand with the main data frame and the converted one. Okay, so this is the main one and this is the converted one. Okay, so we just learned slicing and filtering part over here. Now the next topic is aggregation. In SQL, we have learned aggregation with the group by clause. There are different kind of aggregation, just like summation aggregation, I mean average, maximum, minimum, count. So all those things we have used there during our aggregation. Over here, how to do the aggregation part? Okay, some basic level of aggregation I'll be showing it today, and tomorrow there should be some advanced level of aggregation. So how to use this aggregation? Let me show you. Removing this part. So I'll be grouping the data. Maybe I'm grouping the data on top of department df dot group by. Group by is the method name over here on top of department. Okay, and I can put which function I want to include, whether it's a summation, whether it's a mean, whether it's a count, what kind of things I'll be doing. Mean, it means arithmetic mean. Okay, just like the average. So if I just pass this thing, I'm doing mean, but on top of what? On top of grouping the department. But mean of salary experience, I'm not putting it in this way. So Python interpreter by default, it will be taking the numerical columns and doing the mean part. Okay, if we just do mean, if we just do summation, it will not be applicable on top of date of birth or maybe employee first name, employee last name. For that, we will be also receiving some warning. Let me show you. If we run this group by statement, I run it, can see a future warning is there because if we go ahead with the mean method over here in this way, it will operate on top of numeric value only. But we are receiving some output. The output is a faulty one because you can see, okay, what it happens, the department column is now the index. On top of department, I'm doing the group by. So now department is the index. Based on the department, I'm doing the arithmetic mean on the other field. So for experience, it's fine. For salary, it's fine. But employee ID is also a numeric key. You can see it's a primary key, but it's a numeric one. So it's also picking up employee and doing the average, which is not the good thing. There is no business value. So on top of employee ID, if we are doing this kind of average, this is having no mean. So for this kind of thing, we need to use another functions. I'll be showing this thing in tomorrow's session. We can do separate functions on top of aggregation. I'll be showing this thing in tomorrow's session with some advanced level of aggregation. Okay. But you can check experience and salary. Based on the department, the average experience and salary, it's very fruitful information. So what it's doing, it's grouping maybe on top of IT, there are 4%. Okay. So just it's collecting all the IT people's salary and dividing them by 4. And you can see the result is proper one. Even you can also see the average age or experience for each of the departments. This is also a good business. I mean, maybe business values will be added to the customer. But employee ID, it's a primary key. We cannot do the average. I mean, we can do the average, but there is no business value if we're doing the average in this way. Hope this is understandable. Moving to the next topic. Sorting the data frame. So let's print the main data frame once more time. So you can see the data frame is already sorted based on the index. Okay. With the ascending manner. So we can short it. We can put it in descending manner as well. Let's do how we can short it. We can short in two way, either based on the indexes or based on any existing columns over here. If we want to sort based on index, it's already sorted, which is ascending in nature. But the particular method name is df dot short underscore index. This is the particular method available. Short index means I'm shorting the data frame based on index. Okay. By default, the short index, it's already shorted it ascending in nature. If I print the same thing, there should not be any change actually. Now, if I want to print the data with descending in nature, the index should be organized with descending manner. Then we just need to pass within the parameter ascending equal boolean false. Okay, let me print. This means it's a descending in nature. So you can see ascending equal false means it should be descending. So first it is printing 10, 9, 8, 7, 6. This way it's printing the indexing part. Hope that is understandable. Now I can remove the index part with the sorting portion. I can introduce any key value. Suppose I want to sort the data frame based on any existing, suppose based on salary or based on experience, I'll be sorting it. Based on experience, I'll be sorting it. So just put sort value. Earlier one was sort index. Now I'm putting sort by values, sort values. Then I need to put the column name over here. Experience. Let me put experience. Okay. So the entire data frame is sorted based on the experience. And see, accordingly, the index has also modified over here because the row, whatever row is mentioned over here, it doesn't following the same sorting manner over here as well. So here is a change with the sorting. Okay, hope there is no issue. We can also put ascending and descending part over here as well. Just after declaring this experience, you can put a comma and put the ascending. Okay, and we can use false. We can use multiple multiple column as well. Not only on top of experience, we can use other maybe on department as well. Just like in order by clause, we can put multiple columns. The first one should be having the precedence. If we have the same value in the first column, then which should be coming first? It will be depending on the second field. Okay, so you can use multiple field during the sorting. How to doing the sorting part. Okay, so this is how the sort should work. I think this is the last topic for today. Yes. So whatever we have learned, we have done some extraction part. And after closing the extraction is very, very important. Without extraction, we cannot able to set up a connection with the source system and pull the data from there. So we first learn the extraction. After that, we learn how to do the transformation a bit. But there is lots of things on top of transformation, which we'll be learning in tomorrow's session as well, tomorrow or day after tomorrow, one by one. So after covering the transformation, we'll be going ahead with the data loading part at the target site. So we'll be also learning this part the last day. Okay. So this thing, please practice these things at your home if you have PyCharm or any other Python tool. Just use Python as well as that SQL Alchemy and try to import database and create data frames, as well as please start the transformation part as well. Okay, because Python transformation, there is huge things. Although I'll be just covering the important stuffs over there, but if you just go ahead with the documentation with Python data frames, transformation, different transformation, you can see there are huge things are available. Okay. Okay. So let's connect tomorrow with having some more transformation ideas on top of data frame one by one. So thank you everyone. Thank you joining the session. Bye bye.